Well, hello, and today we're going to be looking at the Troika AniCAM for anilox-qc. This is a small handheld device capable of producing 3D scans and analysis of anilox rolls in ceramic, steel and chrome. So first of all, let's guide you round the device itself. So you can see the device here, sat on a typical label roll. And let's walk you around the device. So there are silicone feet here, and of course on the other side. These protect the anilox roll and give stable positioning of the camera on the roll. There is built-in illumination, which is computer controlled here, and 3 lenses which allow us to adjust the scanning screen range from 100 to 1500 lines per inch. Internally, the optics and mechanics are in this area here. A locking mechanism for transportation. A battery pack here for operation away from mains power support. And a USB connection here to allow us connection to our computer. Positioning the camera on the roll is very straightforward. Simply pick it up and place it on the position you wish to examine, and there we're ready to go. So now we're ready to take some measurements. First of all, let's make sure our settings are correct in terms of our localization, imperial, metric, BCM or cubic centimeters, and so on. I can also allow any purchased optional extras by checking the box. I'm happy there. Now I look at my video window and I can set up a series of default settings depending on what I'm scanning. And these are accessed by the setup bar here. I can take the zoom factor, lighting, and any optional extras I've purchased with the camera. And this allows me to save a quick go-to setting for easy measurement of rolls. I'm at the point of being ready to scan, but it's important that I take several measurements across the roller. This establishes if the roller has the same volume across the web, and that will allow me to eliminate issues that are caused by uneven wear or uneven cleaning. So let's just look at that. The box here allows me to enter the company name, the roll ID, and then establish the measurements I'm going to make. Once I'm happy that that's set up, then I can look at my scan window here. I can make some adjustment just to fine-tune where I am. I want to see the top of the cell walls in this instance. Simply clicking 3D scan will allow the camera to take over. And here we have the first important element. The scanner will take care of the focusing automatically to within 1 micron and the lighting levels to get the best possible results from the scan. You can see in this instance we're actually scanning through the cells. And what I want to make is a series of scans, in this case 150, through the roll and the cell. This establishes if there's any contamination, ink or wear, we can clearly see that. And that is all automatically calculated for us. So now we look at the processing from the computer, and in a matter of moments automatically gain the volume and the depth of the roll. Of course, now I'm going to present in 3 places, so let's do this quickly. So now I've completed my 3 measurements in this instance. Each measurement takes about 60 seconds, so it's nice and quick and easy to generate. I place the camera minimized. I can see my volumes 13.9, 14.2 and 13.9. A consistent depth, so it would indicate that perhaps the cleaning is not so good at the end of the roll. If I click on Proceed, then I will have the average value for the roll, depth, screen and engraving angle. I can also measure, if I wish, the wall and the opening. Simply select the measuring tool, and then I can just generate the wall information. I set that as the wall, and then my opening information, and set that as the opening. You'll see conveniently the measurements stay on the screen, so if I do need to do a multiple analysis, that can be generated. Now we can see that those measurements are transmitted across here. The roll ID has automatically been taken from the setup, so now I need to type in the operator name and some information regarding the roll, and this might be the manufacturer's specification or some other useful information. From here I can generate a report showing me all of the information relating to the roll, the measurements that we took, and the average value that's automatically generated. And here, any comments or signatories that I wish to make. That can be saved as a PDF file or printed out as a paper document to accompany the roll. But of course, we need to know a little more about the condition of the roll itself. So let's have a look at this. First of all, what we're looking at here is the top of the cell walls. We see they're in reasonable condition. But of course this could show things like scoring and missing wall information. The next we want to have a look at is the quality of the ceramic. If I use the tool here, by right-clicking in the video window, I can then see all of the cell information, so each of the 150 scans is all in focus. And here I can have a look and see if there are particular issues with ceramic damage. And if I show you a particular file, you'll understand the importance of this. So I've got a roll here, and to look at, it looks very reasonable, and I could put that onto the press. If I do the same operation again and look here, perhaps my answer to putting it on the press may have changed. You can see here deep ceramic cracking throughout the material, and this will lead to ceramic being deposited into the ink and being trapped by the doctor blade, and will lead to scoring of the anilox and of course its renewal. All the while I could be affecting the print quality. Now of course the other side of this is how effective is my cleaning. And by moving the slider just a little further down, you can see here that the bottom of the cells are in magenta and red, the sidewalls orange, yellow and greens, and the top of the cells in blue. So I can see immediately that these cells here are not very clean, and therefore I need to do something about that. So if I use my electronic knife, I can then cut through the cells to produce an electronic cut through. And we can see here, this cell is not too bad, a small amount of plugging. This cell is obviously very plugged, and this cell a good cell. So it's very easy to obtain the information relating to the quality of the anilox and our cleaning processes. I can also look at the anilox in a three-dimensional space. We've created a three-dimensional model, and this will allow us to see very visually where the errors and wear and cleanliness of the analogs is. And if I look at our much cleaner roll, you can see here, this is the top section, mid section, and then the cleaning. I can, of course, adjust the angle of the viewing and zoom into the detail if I wish to do so. And if I wish to stop it on a particular axis, move that round. So now I have a very visual message regarding the cleanliness of my analogs. Clean, not clean. I know where I'm heading, and I know what I can do to improve the situation regarding the analogs. So, we've measured the analogs, we've understood its condition, we've understood how clean it is. What I need to do now is manage the data. Within the system, we have the ability to export the data into a database management tool, Anilox Management System, and it will export all of this information automatically into the Anilox Management System. From there, we can start to manage our analogs. And we'll cover this in a following video. But thank you for your time, and if you have any questions, please consult with your Troika representative. Thank you.